So when we think of covalent bonds, we know that a covalent bond means that the atoms are going to be sharing the electrons between them. But the question is, do they always share equally? And the answer is no, they do not. And to explain that concept, I want you to think of two little kids, like maybe one who's about 3 and the other one who's maybe 1.5. And so they're sitting together on the floor and they're playing. And the 1.5-year-old picks up a toy that she thinks is pretty cool, and so she starts to play with it. And the 3-year-old looks over and he says, I want that toy. So the 3-year-old, being bigger and stronger and older, comes over and grabs the toy away from the little one, and he takes it for himself. Well, then mommy comes into the room, mainly because the 1.5-year-old is screaming because she just lost her toy. And she says, now, you have to share nicely. So 3-year-old, being obedient, goes over and he shares the toy nicely with his sister until mommy leaves the room. In which case, he grabs the toy and plays with it all by himself again. Eventually, mommy comes back in and says, are you sharing nicely? Oh yes, of course I'm sharing nicely. And so he shares the toy with his sister, and mommy walks out and then he plays with it by himself. So you can see that when mommy's in the room, he shares nicely. When mommy's not in the room, he doesn't share nicely. He's kind of selfish about things. Atoms are kind of the same way. You can think of them that same way because sometimes one atom wants an electron a whole lot more than the second atom that it's sharing with wants that electron. And so they don't actually share it 50-50. They don't share evenly. And so there are a couple of different properties that are called periodic properties that will influence whether electrons are shared equally and how unequally they are shared if they're not shared equally. So there are two properties that we're going to hit. The first one is the atomic radius. And I'm sure you know what a radius of a circle is. It's the distance between the center of the circle and the edge of the circle. And because atoms, we tend to think of them as spheres, they're going to have a radius also. Now, the deal is that the bigger the radius, the less likely they are to pull hard on those electrons. Now, when I say they're going to pull on the electrons, I want you to think back for a second about the structure of an atom. The protons are in the nucleus, and they're in the middle, and the electrons are on the outside. And so protons and electrons are oppositely charged. So the nucleus of the atom, being oppositely charged of the electrons, is going to pull on those electrons and draw them towards itself. So if you think about if you're trying to grab a hold of someone and pull them your direction, if you can only grab a hold of somebody's fingertips and you go to pull them your direction, that isn't nearly as effective as if you can grab somebody by the forearm and grab a hold of them this way and start pulling them. You're going to get a lot further by pulling somebody by the forearm than just yanking them by the fingertips. And it's the same type of thing because you're closer if you can grab by the forearm. Atoms that are smaller are going to be able to pull harder on electrons than atoms that are bigger. And so when you think about the periodic table, hopefully it is obvious to you that as you go down the periodic table, for every row that you go down, you are adding an energy level of electrons. And one way to think about that is it's like adding a layer of an onion. So every layer that you add gets bigger and bigger and bigger. And so every energy level that you add on an atom is like adding another layer to it. And so adding another energy level makes the atom bigger and bigger and bigger. So as I go up the periodic table, the atom is going to get smaller in radius. Now the other question is what happens as I go across the periodic table? This one's a little bit tricky, so you have to think about this one. As I go across the periodic table, I am adding protons. Every time I go across, I'm going up in atomic number, so I'm adding a proton for every element that I go across the table. So if you think of lithium, which is on the left side in the second row on the periodic table, it's going to have 3 protons And by the time I get to the end of that row, I've added 8 electrons, or 8 protons as well. And so now I'm up to 10. So I've got from 3 all the way up to 10 in neon. The number of protons has gone up. The number of electrons has gone up too, but the difference is all those electrons are in the same energy level. So they're in the same layer of the onion, so to speak. But my nucleus is now able to pull a whole lot stronger, and so it can actually pull the electrons in tighter than it could if it only had one, just because there's so many electrons in there, or so many protons in the nucleus, that they exert a much greater pull on that electron shell than they did when they had fewer electrons on the left-hand side. So as I go across the periodic table to the right, because I get more and more protons the more I go across, but I haven't increased the number of shells that I have, the nucleus pulls harder and harder, and it just kind of sucks that outer layer of electrons in tighter because it pulls so much harder. So atomic radius, as you go up the periodic table and to the right, the atomic radius will become smaller. Okay. The other characteristic that we want to look at is electronegativity. And electronegativity, even though it's a big word, it just simply means how strongly are you attracting electrons to yourself. How strongly an electron is attracted to an atom. Now, once again, we're going to look at the periodic table. And if I go up the periodic table, what I find is that the nucleus, again, has fewer energy levels to pull through, and so the electrons are wanted a whole lot more by that atom the fewer energy levels that I have, because it wants to gain more and more atoms. So as I go up the periodic table for electronegativity, it actually increases. As I go to the right across the periodic table, the electronegativity increases as well. And the reason is because if you think of the things on the right side of the periodic table, you have to kind of ignore the noble gas column temporarily. But if I look at the second column over, fluorine, chlorine, bromine, iodine, those elements right there, they only need one more electron to be completely satisfied and have their valence shell full. You go to the next one to the left, they need 2 electrons, then 3, then 4. And if you remember, we said that when you get to the left-hand side, they don't try to pull electrons anymore. They're trying to get rid of electrons, because it's easier to get rid of 1 electron than it is to gain 7 so that your outer shell is completely full. So as you go up the table and as you go across the periodic table, the atoms are pulling harder and harder to gain electrons, and so the electronegativity, their desire for the electrons, is increasing as you go up and to the right across the periodic table. Okay, they're called periodic properties because you can predict them by looking at the periodic table. So let's do a couple of examples. Let's say that I want to put in order these particular elements in order of increasing radius. And you will have some problems that you're going to be doing like this in your book. So we're going to look at 4. We're going to look at argon. We're going to look at phosphorus. We're going to look at magnesium. And we're going to look at aluminum. Okay? So now if you pull your periodic table and you look at it, what you will see is that all 4 of these elements are in the same row on the periodic table, correct? So we already said that the increasing radius in our little chart over here, it increases as I go across, or gets smaller rather, as I go across the periodic table. This is asking for order of increasing radius, so it wants them in order of how the radius is going to get bigger. All of these are in the same row. So the one to the furthest to the right is going to have the smallest radius. Well, the element here that's the furthest to the right is the argon because it is the noble gas. So the argon is going to have the smallest radius. So actually, since I want increasing radius, I need to put argon first. Don't want to confuse you there, got it backwards. As I go across the periodic table this direction, I'm going to get to phosphorus next. And as I keep going across the periodic table this way, then I come to aluminum. And then finally, I'm going to get over here and I'm going to come to magnesium. Okay, so if you don't have your periodic table, you probably need to pull it out and look at those elements to see exactly where they all are located. But in order of increasing radius, the further I go to the left, the larger that radius is going to become. And remember, the reason is because I don't have as many protons in the middle on the left-hand side to pull as I do on the right-hand side. Okay, let's do a similar problem where I'm going to put some elements in order. And this time we're going to do it in order of increasing electronegativity. And I'm just to shorten this up right now, I'm going to put En for electronegativity. I'm going to use nitrogen and antimony and arsenic. And again, get your periodic table out and look at these. You will see that all of these are in the same column on the periodic table. And because they're in the same column, electronegativity increases as I go up. So the one with the smallest amount of electronegativity is going to be the antimony because it is the lowest on the periodic table. And then as I climb my way up that column, the next one I come to is arsenic, and then I will find nitrogen in the top row. So this is in order of increasing electronegativity. These here are in order of increasing radius. So even though I've drawn these arrows the same direction because I think thinking going up and across will help you to remember them, remember that this makes radius go down, but it makes electronegativity go up. You do have some charts in your book where they have that drawn on there for you, but I want to caution you because you won't be given charts like that on the test, and you need to remember these particular periodic trends and be able to put elements in order of increasing, decreasing atomic radius or electronegativity with only a plain old periodic table. So you need to make sure that you have this concept down so that you can utilize that.